The blades of a wind turbine are of length 32 meters. The point A on the tip of a blade traces out a circle as the blade rotates. Using pi as 3.14, calculate the distance traveled. Calculate the distance traveled by the point A in one revolution. So we need to figure out the distance traveled in one revolution. Now, what they basically are asking us is to figure out the distance, all right, the distance of this circle. So what they basically want us to figure out is the circumference of the circle. And so that is what we have to figure out, right? So the distance traveled by one point in one revolution, because one revolution is going to cover this distance, and this distance is exactly the distance of this circle, right, in one revolution. So it's going to go all the way around, covering this distance. So what we basically have to figure out is the distance that this point is going to travel around the circle. So we basically have to figure out what is the distance of the circle. And the distance of the circle is given by the formula 2 pi r, because that's the circumference of the circle. That's basically what the question is asking us for. What is the circumference of the circle? That's basically what they're saying. Now, the formula for the circumference of the circle is 2 pi r, where pi in this case is 3.14, and the radius is already given. The radius is 32 meters. And so we have to multiply. We have 2 times 3.14 times 32, and that gives us, when we multiply 2 times 3.14, that gives us 6.28. And then we have to multiply by the radius, which is 200.96 when we multiply them. So when we take 6.28 and we multiply by 32, we get 200.96 meters. And that's the circumference of the circle. That is the distance traveled by the point in one revolution. This is very important. And so let's move on to the next question. It says, the blades are rotating at 12 revolutions per minute. Calculate the speed of the point A in meters per second, all right? Okay, so what do we have? Well, we know that the blades are rotating at 12 revolutions per minute. So this is 12 revolutions per minute. Okay, what is a minute, right? A minute is what? A minute is 60 seconds. So if they say 12 revolutions per minute, what they actually mean is 12 revolutions per 60 times 1 second. So 12 revolutions per 60 seconds. So that means that the blades are rotating 12 revolutions per 60 seconds, all right? So that's what we have, right? So 12 revolutions per 60 seconds, or 12 revolutions per minute, all right? Okay, now what else? Well, we know that one revolution, what is the distance of one revolution? Well, we just figured that out, right? The distance of one revolution is 200.96, right? 200.96 meters. So if you're trying to figure out the distance of 12 revolutions, you're just going to take 12 and multiply it by 200.96. And so that means that the blades are rotating at, when we multiply these two, we have this number is 2411.52 meters. And what is that number? That is 2,411.52 meters per 60 seconds. So the blades are rotating at 2,411.52 meters per 60 seconds. So every 60 seconds, this is the distance that will be covered. So every 60 seconds, we have 2,411.52 meters every 60 seconds. So if this is the distance that is going to be covered in 60 seconds, then what is the distance that is going to be covered in 1 second? All right. So we know that 2,411.52 meters, that's the amount, that's the distance that is covered every 60 seconds. So if you want to figure out the distance that is covered in 1 second, we just have to divide this distance by 60. And so we have 2,411.52 divided by 60, and that's how much meters that's the distance that will be covered every second. And when we divide it, we get 40.192 meters. And so this is the amount of meters that will be covered, or this is the amount of distance that will be covered every second. And so that means that the speed of the point A in meters per second is 40.192 meters per second. And that's the answer to this question. So if we want to write this answer explicitly, we have the speed of the point at A in meters per second is equal to 40.192 meters per second. And that is our final answer to this question. The speed of the point at A in meters per second is equal to 40.192 meters per second. Again, 40.192 meters per second is our answer.